Hello students, welcome back to MEMONEET. This is Aprajita, your chemistry SME. I hope all of you are doing good and all of you are preparing well for the next Brahmastra part test. I hope the preparation is going well, students. In case you are having any issues and doubts, you can contact us. You can comment below in the YouTube comment section, or you know that there is a Telegram group which we are running for you people. So you can contact us there and you can ask your doubts there as well. Okay. So I hope equilibrium chapter is being clear to you. We have uploaded the first 2 video lectures for this chapter, which will be helpful for you for the preparation. So today I'm going to upload the third part, that is the last one. We will be studying that part today and the chapter would be complete and you will be ready for with this chapter. Okay, so basically what did we learn in the last lecture? Last lecture was basically about the Le Chatelier's principle. So we discussed the Le Chatelier's principle and we also studied about the various factors that affect equilibria and how they will affect the equilibrium. That is based on Le Chatelier's principle. Okay, we saw the change in concentration, temperature, pressure, and how catalyst also affects it. So this Le Chatelier's principle is important because questions will be asked on the applications. Okay, and now today we will be focusing. So for today, what we are going to discuss, we will be learning about ionic equilibrium. So till now we were discussing about chemical equilibrium. Today we'll be talking about the ionic equilibrium. Now today's session is like totally dedicated to this, where we'll be talking and studying about acids, bases and salts. Then we will see the strength of acids and all of that. Then we will be talking about the pH scale, how to find the pH, because from this section now in Neet you will be getting a lot of numericals, which is important. So in this section you will be getting a lot of numericals in the Neet examination. That's what make it an important section of this chapter. Okay, earlier whatever we did, yeah, a few numericals will be asked, but mostly theoretical was there. So from this section you will be asked the numericals. Okay, so today we will be covering the theory portion. Whatever topics are there in this ionic equilibrium, I'll be covering that. Okay, so stay till the end and we will be discussing the important topics as well. All right. So let us first see what is ionic equilibrium. If I am talking about equilibrium, then what is ionic equilibrium? See, there are numerous equilibrium that involves ions only. Okay, so ionic equilibrium means the equilibrium that is just related with ions. Okay, so we will be talking about the equilibrium that involves ionic species. Okay, like we know that aqueous solution of sugar does not conduct electricity, but aqueous solution of salt conducts electricity. Okay, and if I am adding more salt to it, the conductance of electricity will also increase. So there was a scientist, Michael Faraday, who classified these substances into 2 categories. Now on basis of their ability to conduct electricity, whether they conduct electricity or not. Okay, so one category of substance that conduct electricity in their aqueous solutions, he called it electrolytes. Okay, this is important. He called it electrolytes. So there must not be any confusion about this particular word. We use it in many places. We have studied it in electrochemistry also. Okay, so these category of substances that conduct electricity in their aqueous solution are called electrolytes. The ones that do not conduct electricity in the aqueous solution, we will be calling them as non-electrolytes. Okay. Now, electrolytes are of 2 types, strong and weak electrolyte. Now, strong electrolyte, what is the difference in these two? Strong means the ones that are completely ionized when we dissolve them in water. Okay, the ones that are completely ionized, while the weak electrolytes will be the one that will be partially ionized or partially dissociated. Like if I am talking about sodium chloride, तो sodium chloride का जो aqueous solution होगा, it will mainly be having sodium ions and chloride ions, because it is a strong electrolyte and all of it, like the ions, will be completely dissociated in water. Okay, like if I am talking about acetic acid, CH3COOH, it's a weak electrolyte. Okay, so it will mainly be having unionized acetic acid molecule and some acetate ions, that is CH3COO negative ions, and some hydronium ions, or you can say hydrogen ions basically. So it is a weak electrolyte. Okay. So weak electrolyte, like only 5% ionization is happening, like only 5% of the molecules will ionize, rest will remain as it is. So in case of weak electrolytes, I can like you can see here I have shown the equilibrium sign. So equilibrium is established between the unionized molecules and the ions. Okay. So this is the equilibrium that is known as ionic equilibrium, that is the equilibrium involving ions in aqueous solutions. Okay. So this is the equilibrium which we will be talking about. So mainly we need to talk about or learn about the electrolytes. So which substances are actually acting as electrolytes? Acid, bases and salts. They are the ones that come under the category of electrolytes, and they can act as weak or strong electrolyte. Okay. So we will be mainly talking about what are acids and bases. So there were various concepts that were given by the scientists for the definition of acids and bases. And those concepts we are going to learn. You might have heard about it in lower classes also, but here we will be talking about the different concepts of acids and bases. So the first concept was given by Arrhenius. So Arrhenius name you might have studied many a times. Okay, we have studied Arrhenius equation also and all of these things. So this is your Arrhenius concept of acids and base. So according to Arrhenius theory, acids are the substances that dissociate in water to form hydrogen ions or to give hydrogen ions, whereas bases are the substances that dissociate in water to give hydroxyl or hydroxide ions, OH negative. Okay, see, this is the simple definition. If any substance is giving you hydrogen ion when you dissolve it in water, it will be an Arrhenius acid. And if any substance is giving you hydroxide ion, it will be an Arrhenius base. So here you can see that HX is an Arrhenius acid, because in water or in aqueous medium it will be giving you H plus and X minus. So this is an Arrhenius acid. Okay. Whereas if I am talking about this thing H plus, now this is just a proton. You know hydrogen has one electron and one proton, so H plus is just a proton. And now this proton is highly reactive and highly unstable. If it is very reactive, it is unstable and it cannot exist freely in aqueous solutions. So what it will do, it will combine with the oxygen of the solvent water molecule to form an hydronium ion, trigonal pyramidal in shape. Okay, H3O positive ion, this is known as hydronium ion. Okay, so don't get confused with H plus or H3O plus. In some cases H plus will be written, in some cases H3O plus will be written. Okay, so that is the same thing. It's just that H plus can't exist freely in aqueous medium, so it combines with water and it exists as H3O plus, which we call as hydronium ion. Similarly, if I am talking about the base molecule like MOH, it ionizes aqueous medium and it will be giving you M plus and OH minus. Okay, so these hydroxyl ions, they also exist in the hydrated form in aqueous solution. All right, now so this was the Arrhenius concept of acid and base, but it again had some limitations because it was applicable only to aqueous solution. And let's say if I am having ammonia, okay, ammonia we all know it's a base, but according to Arrhenius concept, it could not explain the basicity of ammonia because it is not having any hydroxyl group. Okay, and according to Arrhenius, or if hydroxyl ion is released, then it will be a base. So there were certain limitations for this concept. So okay, then the next concept came up, which is the Bronsted-Lowry concept of acids and bases. So there were two scientists, Johannes Bronsted and Thomas M. Lowry. They gave a more general definition. Okay, so this was more generalized. That was applicable, Arrhenius was applicable only for aqueous solutions, but it was more general. Okay, so according to this theory, acid is any substance that is capable of donating an hydrogen ion, or you can say it is capable of donating a proton. Instead of hydrogen ion, just say proton. Okay. Whereas according to this theory, base is a substance which is capable of accepting a hydrogen ion, means accepting a proton. So in short, they said acids are proton donors and bases are proton acceptors. Okay. Now using this concept, you can explain the basicity of ammonia. Okay. Now in ammonia, if I am talking in aqueous medium, so you have water. In that case, water will be acting as the acid. So water will be donating its proton to ammonia. Okay. And ammonia will be forming ammonium ion and water will be left with hydroxyl ion. So there is an addition of proton. Okay. Ammonia is accepting the proton from water and proton acceptors are called base. So that is why we can say ki here ammonia is acting as a base. And here you need so the resultant solution, if you dissolve ammonia in water, you will be getting ammonium hydroxide. So this is again basic because of the presence of hydroxyl ions. Okay. So I have explained you in this reaction, water will be acting as a proton donor and ammonia acts as a proton acceptor. Okay. Alright, now if I am talking about, so there will be an equilibrium between it ना. So जब भी हम equilibrium की बात करेंगे, we will be talking about the reverse reaction also. So in the reverse reaction, hydrogen ion is transferred from ammonium, or like you can say proton is transferred from ammonium ion to hydroxyl ion. So in this case, ammonium ion will be acting as the Bronsted acid. Okay. Bronsted acid, whereas hydroxide ions is acting as a Bronsted base. Okay, so ammonia was a base and the ion that it is forming, ammonium ion, it's an acid. Okay, so they are just differing by one proton. एक proton का difference है यहाँ पर, and we will be calling it as a conjugate acid base pair. So this was a base and its ammonium ion is its conjugate acid. Okay, and you can say hydroxide ion is the conjugate base of water. All right, and you have to keep that in mind कि if Bronsted acid is a strong acid, then its conjugate base will be a weak base. Okay, and vice versa. So conjugate acid has one extra proton and conjugate base has one less proton. Keep that in mind. All right, so this is conjugate acid base concept. Now we will be saying one more example if I am talking about ionization of HCl in water. So HCl is acting as an acid in this case and water is acting as a base. So HCl will donate its proton and it will get converted to chloride ion. Now this chloride ion will be the conjugate base of HCl. Okay, because in the reverse reaction you will see that it will accept a proton from hydronium ion. And now water, it was acting as a base in this case, okay, because it is accepting a proton and getting converted to hydronium ion. Okay, so hydronium ion is the conjugate acid of water in this case. Okay, so that's what we have understood from the conjugate acid base concept. Now here you can see about water, that water was acting as a base in the case of ammonia, sorry, acid in the case of ammonia. All right, but it is acting as a base in the case of HCl. So water is the one that can act as an acid also and can act as a base also. Okay, so this is your conjugate acid base concept. Now we will be talking about the Lewis acid and bases. So students, in the Lewis acid base concept, so Lewis defined an acid as any species which accepts the electron pair. Okay, so in this case, he actually defined the acids and bases in terms of electron pair, because you know ki electrons are the ones that are transferred during the reaction. So electron pair acceptor are the acids and bases are the ones which are electron pair donors. Okay, or they donate the electron pairs. Okay, so here in this case the base is providing the lone pair of electrons. Okay, so as you can see here, if we are talking about the reaction of BF3 with NH3, BF3 is not having a proton. Okay, so this concept actually explains about the acidity of many substances like BF3, AlCl3, which are not having any proton but still acting as an acid because they are accepting the electron pair. So you know कि BF3 is an electron deficient species. Okay, boron is just having 6 electrons around the outermost shell, so it needs 2 more electron. Whereas ammonia में nitrogen, we have studied chemical bonding, it is having a lone pair. So this lone pair of electron, okay, this lone pair of electron will be donated to BF3 to form a coordinate bond. So here NH3 is acting as a Lewis base and BF3 is acting as a Lewis acid. Okay, same goes with aluminium chloride, CO3 plus, Mg2 plus. So these are the ones which are accepting electron pairs and then acting as Lewis acid. It is not necessary that they will have proton only. Okay. So that was like about the different concepts of acids and bases. Now we'll be talking about the ionization of acids and bases. So let's say if we are having two acids, HA and H3O, which are present in this acid dissociation equilibrium. So you can say कि HA in water gives H3O plus and A minus. अब हमें देखना क्या है? We need to see actually कि we have studied about equilibrium now, but we need to see ki in which direction the reaction will proceed. Will it proceed in the forward direction or in the backward direction? For that we need to know which one is the stronger proton donor. Okay, so we will find out the stronger proton donor. So which one, the one having more the one having more tendency to donate the proton will be termed as the stronger acid. Okay, and it will dissociate, means the equilibrium will shift in the direction of weaker acid. Okay, let's say if HA, here we are considering ki HA is a stronger acid than H3O plus. Okay, so means HA will have tendency to donate protons to H2O and not H3O plus will do it. Okay, so means the reaction will proceed in the forward direction if HA is a stronger acid, and the solution, your solution will be mainly having hydronium ions and A minus ions. Okay, so you need to keep in mind, since we are studying equilibrium, कि the equilibrium moves in the direction of formation of weaker acid. ओके, और वीकर बेस, बिकॉज स्ट्रॉन्गर एसिड जो है वो डोनेट करेगा प्रोटॉन टू अ स्ट्रॉन्गर बेस. ओके, so this is how ionization will happen. Now you know कि जो strong acid है it dissociates completely in water and जो resulting base बनेगा that would be very weak, because we have seen कि strong acids have weak conjugate bases. Like example, if we have perchloric acid, hydrochloric acid, hydrobromic, hydroiodic acid, nitric, sulfuric acid, so they will have these conjugate bases. Okay, Cl minus. So all of these are much weaker bases than water, because strong acids have weak conjugate bases. Similarly, if you have a strong base, it would give a very weak conjugate acid. Okay. Now, if I am talking about a weak acid, let's say HA is a weak acid, so it will be partially dissociated in aqueous medium. Okay, so it will be mainly having undissociated molecules. Okay, क्योंकि in that case you will be having undissociated molecules. Okay, so more of HA will be present, and so equilibrium will be shifting towards the HA. Alright, means the backward direction. So typical weak acids like nitrous acid, HF, hydrofluoric acid, acetic acid are the examples. So these weak acids, they are actually having very strong conjugate bases like NH2 minus, O2 minus, H minus. They are good proton acceptors than water. Okay, much stronger bases than water. You know, you might have studied about indicators. आपने देखे होंगे like indicators, acid base indicators we have like phenolphthalein, bromothiamyl blue. Like, so these are actually weak acids and they exhibit different color in their acid and their conjugate base form. Okay. So like if you have any indicator, so these are weak acids, so they'll dissolve in water to form conjugate acid and conjugate base. So in acidic form it will have, let's say, color A, but in conjugate base form it will have color B. तो ये जो color change है, this is what helping them to act as the indicator. We use them in acid base titration or to find out the hydrogen ion concentrations. Okay, so that is again an example of an acid base equilibrium. Okay. Now students, another important thing is ionization constant of water and its ionic product. Now you know कि water has this ability of acting both as an acid and base. In presence of acid, that is Ha, it will accept a proton and act as the base, while in the presence of base it will be acting as an acid by donating the proton. Let's say if pure water molecule we have, let's say water में self ionization हो जाती है. In water you will be having self ionization, means one molecule will be acting as the acid and one molecule will be acting as the base. So in water you will be having somewhat of the hydronium ions and hydroxide ions, so this equilibrium will be existing. Now if you have to write down the dissociation constant, so again K is equal to concentration of product by concentration of reactant, but यहाँ पर we omit the concentration of water, क्योंकि water is a pure liquid and उसकी concentration constant रहेगी. We have studied it in equilibrium constant also कि प्योर लिक्विड और प्योर सॉलिड की कंसंट्रेशन हम कंसिडर नहीं करते, तो दैट इज कांस्टेंट, उसको हम इक्विलिब्रियम कांस्टेंट में ही incorporate कर देंगे and we will be getting a new constant. So that new constant is called the ionic product of water. So now you know कि ionic product of water means the product of concentration of hydrogen ions and hydroxide ions. This is called ionic product of water. Okay. Now this concentration of hydrogen ion has been found out as 1.0 into 10 to the power minus 7 molar at specific temperature, means at 298 Kelvin. And dissociation, you know कि water की जब dissociation होगी you will be getting equal number of hydrogen and hydroxide ions. So concentration of hydroxide ions also will be same. So K W means ionic product की value क्या आ जाएगी, 1 into 10 to the power minus 7 square. So that will be 1 into 10 to the power minus 40. And it is at, of course, 298 Kelvin. Okay, means 25 degree Celsius. So because this will be temperature dependent as it is an equilibrium constant. It is nothing but equilibrium constant only. Okay. So now let us talk about the pH scale. So students, basically in pH, what do we represent? We represent the hydrogen, or you can say hydronium ion concentration. Okay, this is what we are expressing with the help of pH scale. Okay, P means power of hydrogen, we say. Okay, power or potence of hydrogen. So if we are expressing it on the logarithmic scale, we call it as pH. Now pH is defined as the negative logarithm to the base 10 of the activity of hydrogen ion, means negative log of hydrogen ion concentration is known as the pH. Okay, so if I am talking about dilute solutions which have a molarity of less than 0.01, so activity of hydrogen ion is equal to the magnitude of molarity. Okay, so activity actually is not having any units and it is defined as hydrogen ion concentration divided by mole per liter. Okay, so from the definition of pH here, they have just derived the expression of pH. Don't worry more about it, just try to understand that it is actually a quantity, you can say, we are using, or a scale that we are using to represent the hydrogen ion concentration for acids and bases. Okay, let's say if I am having any acidic solution of HCl which is having a molarity of 10 to the power minus 2, so it has a pH of 2. Alright, similarly, if we are having a basic solution of NaOH having hydroxide ion concentration 10 to the power minus 4 and hydronium ion concentration 10 to the power minus 10, so it will have a pH of 10. Okay, so just now we have seen ki at 25 degrees Celsius concentration of hydrogen ions is 10 to the power minus 7 molar in water. So pH of pure water is minus log of 10 to the power minus 7, so that is going to be 7. Okay, so जो pure water का pH होता है 25 degrees Celsius is 7, that we all know. Okay, so how we are describing acids, and based on that, so you already know acids have a concentration of large concentration of hydrogen, and because you know hydrogen ion donors होते हैं, they are proton donors, so they have large concentration of hydrogen ion, तो इनकी concentration जो है it is more than 10 to the power minus 7, and basic solutions have a concentration of less than 10 to the power minus 7. So you can say, this is important, that the acidic solution have a pH of less than 7 and basic solutions have pH of more than 7, and neutral they will be having pH of 7. Okay, so if we consider that equation that we have seen, that ionic product of water is 10 to the power minus 14. Okay, if you have to find out POH means अगर हमें हाइड्रोक्साइड आयन की concentration like pH find करना है, power find करनी है, so from here you can say taking negative logarithm on both side, so यहाँ से it will be pKw and यहाँ पर आ जाएगा minus log of 10 to the power minus 14. So just keep that in mind कि always the sum of pH and POH कि हाइड्रोजन आयन एंड हाइड्रोक्साइड आयन के जो सम है that will always be 14. So अगर आपको POH निकालना है, if you know the pH, you just subtract it from 14. Okay, so this is just we are doing at standard temperature, that is 298 Kelvin. Now let's see the ionization constants of weak acids and bases. So you know that you might have studied this in solutions also. Okay, we have already studied the dissociation constant, degree of dissociation, ये सब हम पढ़ के आ चुके हैं, right? So you know कि weak acid will be partially ionized in the aqueous solution. Okay, so let's say initial concentration of the acid is C and the concentration of ions would be 0. Now alpha is the extent of ionization. Okay, अगर alpha जो है वो extent of ionization है, तो at equilibrium देखो अगर initial जो है वो क्या है C00, okay, for acid and for the ions, और कितना यूज हुआ, लेट्स से extent of ionization जो है वो alpha है, तो at equilibrium हमारे पास कितना बचेगा, how much will be left, C minus C alpha, और यहाँ पर C alpha and C alpha बन जाएगा, alpha is the degree or extent of dissociation. Okay, so C is the initial concentration of the undissociated acid, and at times t equal to 0, alpha is the extent up to which HX is ionized, कि कितना HX ionize हुआ है, that will be alpha. So यहाँ से अब हम basically कर क्या रहे हैं students, we have already studied about this alpha and all, so we are just trying to derive the equilibrium constant in terms of alpha. तो अब concentration आप लिख सकते हो, so K क्या हो जाएगा, C alpha into C alpha upon C minus C alpha. ओके, सो यहाँ पे लिख सकते हो सी स्क्वायर अल्फा स्क्वायर अपॉन सी इंटू 1 माइनस अल्फा, सी से सी कैंसिल हो जाएगा, सो इट विल बी सी अल्फा स्क्वायर अपॉन 1 माइनस अल्फा, दिस विल बी द डिसोसिएशन कांस्टेंट ऑफ एसिड. ओके, एंड इसको मोलर कंसंट्रेशन की फॉर्म में भी हम लिख सकते हैं, वी ऑल नो दैट. ओके, सो दिस इज के ए. अब एसिड की बात कर रहे हैं, सो इट विल बी नोन एज के ए, डिसोसिएशन और आयोनाइजेशन कांस्टेंट ऑफ एसिड. निकाला हमने क्या है, इक्विलिब्रियम कांस्टेंट ही निकाला है, डोंट वरी अबाउट दैट, बट वी विल बी कॉलिंग इट एज आयोनाइजेशन कांस्टेंट ऑफ एसिड. ओके, एंड यू नो कि ये जो के ए है, इट इज इंपॉर्टेंट बिकॉज इट इज अ मेजर ऑफ स्ट्रेंथ ऑफ द एसिड. ओके, हाउ, बिकॉज जितनी ज्यादा के ए की वैल्यू होगी, स्ट्रॉन्गर विल बी द एसिड. ओके, right, larger the value of Ka, stronger will be the acid, keep that in mind. All right students, So now students, we will be describing another one quantity, that is pKa. Okay, so you know ki if I am talking about pH, pOH, so it is negative of logarithmic of anything whatever we are taking. So here we are taking Ka, so pKa is equal to minus log of Ka. So if we know the ionization constant of the acid and initial concentration, okay, it is possible to calculate the equilibrium concentration of all species, the degree of ionization also, and pH also. Now this is the thing where the numericals will be asked from. Okay, they can give you, they can ask you anything. They can ask you about the equilibrium concentration, they can ask you about degree of ionization, that is alpha, or they can ask you about the pH of the solution also. Okay, हाँ पीके के बारे में वन मोर थिंग, यू नो कि जितना स्ट्रॉन्ग, जितनी ज्यादा वैल्यू के ए की होगी उतना ही आपके पास स्ट्रॉन्गर एसिड होगा. एंड यू नो कि इफ के ए की वैल्यू ज्यादा है तो पीके ए की वैल्यू उतनी कम होगी. सो स्ट्रॉन्ग एसिड्स हैव अ लो पीके ए वैल्यू. ओके, कीप दैट इन माइंड. So how we can find out, these are the steps. These steps will be more clear when we'll be talking about the numericals, but here you can see ki the species that are present before dissociation, we take them as Bronsted Lowry acid or base. Okay, we will balance the equations. Balancing is important. All right. So the reaction with higher Ka value will be the primary reaction. The other one will be the subsidiary reaction. Okay, so we have to write in tabular form everything. So we'll be writing the initial concentration, change in concentration, like in terms of alpha, that is your degree of ionization, equilibrium concentration. Okay. So we will be just substituting the equilibrium concentrations into equilibrium constant equation. You know equilibrium constant equation kya hai, right? In terms of concentration, you all know this is how we can write. Okay, and in terms of degree of dissociation also, C alpha square upon 1 minus alpha. And if you have any acid, like in terms of concentration, H plus upon X minus, and here HX. Okay, that's what we will be taking. So yahan se you can find out the value of alpha. And then using this you will get alpha, you will get the value. If you know the value of Ka, you can find out the concentration also. And pH, we all know pH is minus log of hydrogen ion or hydronium ion concentration. So these things will be used in the numerical portion. Same goes students with ionization of weak bases also. Base ke case mein you will be calling it as base ionization constant. The only difference is it will be Kb. Kb will be again concentration of M plus OH minus divided by the concentration of MOH. And again, if C is the initial concentration and alpha is degree of ionization, so it will be C alpha square upon 1 minus alpha. So these two relations you have to remember for Kb. And again, see again, Kb means higher Kb value means stronger base. Okay, so pKb will be minus log of Kb. All right. So what is the relation between Ka and Kb? So you know Ka and Kb will be giving you, if you multiply it, they will be giving you the equilibrium constant for the net reaction. Okay. See, equilibrium constant for net reaction can be obtained after adding two or more reactions. It will be the product of equilibrium constants. Okay, तो net reaction के लिए अगर आपको निकालना है, just multiply the equilibrium constant. So for conjugate acid base pair, Ka into Kb will be Kw. Okay. And if you take the negative log both sides, again you know pKa plus pKb will be 14. So keep that in mind. pH and pOH will also be 14 and pKa plus pKb will be also 14. तो जो आपका pH scale होता है, it is from 0 to 14 only. Okay, so less than 7 are acids, 7 to 14 are bases, and 7 is neutral. All right. So these expressions are important for solving the numerical. Now let's understand the common ion effect, which is important. Let's say if I am dissociating, considering dissociation of acetic acid. Okay, so this is your acetic acid. It will dissociate to form hydrogen ions and acetate ions, or you can write HAC. AC means acetate ions. Okay, AC stands for acetate ion. Don't get confused, means CH3COO negative. तो यहाँ पे हमने लिख दिया HAC gives H plus and AC minus. Okay, so Ka क्या होगा यहाँ पर? Dissociation constant will be H plus concentration of acetate ion and concentration of the acid. Okay, now what will happen? Let's say if I am adding acetate ions. Okay, अगर मैं इसमें acetate ions और डाल दूँ, what will happen? It will decrease the concentration of hydrogen ion also. क्यों? क्योंकि if I am adding acetate ions also, what will happen? It will combine with hydrogen ions and it will form the acid again. So उससे hydrogen ion की concentration भी कम हो जाएगी. Okay. Also, if I am adding hydrogen ions, अगर मैं external source से hydrogen ions add कर रही हूँ, so equilibrium again moves in the direction of undissociated acetic acid. तो हमने यह भी हम पढ़ चुके हैं last reaction में कि अगर हम यहाँ पर वी आर इंक्रीजिंग द कॉन्सेंट्रेशन ऑफ प्रोडक्ट की अगर हम कॉन्सेंट्रेशन बढ़ा रहे हैं तो इट विल ट्राई टू रिवर्स दैट इफेक्ट. मीन्स इट विल ट्राई कि प्रोडक्ट जो है वो कम हो जाए, मतलब it will go in the reverse direction. Okay, means in the direction of reducing the concentration of hydrogen ions. So this is again, in this case we will be calling it as a common ion effect. Okay, so what is common ion effect? Try to understand. It can be defined as a shift in equilibrium on adding a substance that provides more of an ionic species. अगर हम ions की concentration बढ़ा रहे हैं यहाँ पर, so whatever shift in equilibrium happens, okay, that we will be calling it as common ion effect, and it is again based on your Le Chatelier's principle only. Okay. So let's say if I am see questions कैसे आएंगे, numericals will be asked on this. So let's say if you are having 0.05 molar acetic acid solution, उसकी dissociation हो रही है and you are adding 0.05 molar of acetate ion again. हमने उसमें acetate ion और add कर दी, तो अब हमें उस resultant solution का pH निकालना है. Okay, तो initial concentration, what was initial concentration? 0.05 for HAC and 0.05 of acetate also. अब let's say कि X is the extent of ionization. तो चेंज इन कंसंट्रेशन कितना होगा? 0.05 माइनस एक्स, H प्लस कितना हो जाएगा x, एंड यहाँ पर 0.05 प्लस x. नाउ जस्ट पुट द वैल्यूज. ओके, पुट द वैल्यूज इन द Ka एक्सप्रेशन, दैट इज H प्लस AC minus and HAC. So you will be putting the values. Now Ka is very small for weak acid. It's a weak acid, so Ka जो है वो बहुत कम वैल्यू होगी. तो it means the x will be alright, will be very much less than 0.05. So ये आपका जो है x will be very much less than 0.05, your denominator. Okay, और 0.05 plus x और 0.05 minus x को हम लिख सकते हैं 0.05. Okay, so just put the values here, and from here the A value of x. X means the hydrogen ion concentration will be 1.8 into 10 to the power minus 5. अब hydrogen ion concentration आ गई, so you will just find the pH taking minus log of that concentration, which is 4.74. So this is how we will be finding out the pH in terms of common ion effect. Okay. Now students, we were talking about acids and bases. Now let's talk about salts also. Ki when you hydrolyze the salt, when you put the salt in water, what kind of reactions takes place and what will be the pH of the solutions. Okay, so you know ki salt formed by the reaction between acids and bases, they undergo ionization in water. So जो cations और anions बनते हैं students, you know they exist as hydrated ions or they interact with water to reform the corresponding acid or base. वो acid या base बन जाता है या they exist as hydrated ions, depends on the nature of salt. Okay, so जो दूसरा प्रोसेस होता है कि जो आपकी आयंस हैं वो वाटर के साथ इंटरेक्ट करके फिर से आपको वही एसिड और बेस दे दे जिससे वो सॉल्ट बना है, उस प्रोसेस को हम कहते हैं हाइड्रोलिसिस. सो इन दैट केस द पीएच ऑफ द सॉल्यूशन गेट्स अफेक्टेड, पीएच चेंज होगा ऑफ कोर्स. ओके, राइट. सो अभी डिफरेंस हमें पता होना चाहिए. जो आपकी केटाइंस हैं स्ट्रॉन्ग बेसिस की, लाइक सोडियम, पोटेशियम, कैल्शियम, बेरियम आयंस, और एनायंस ऑफ स्ट्रॉन्ग एसिड्स, दे गेट हाइड्रेटेड. वो हाइड्रेटेड रहते हैं बट दे डू नॉट हाइड्रोलाइज. ओके, सो इसी वजह से जो सॉल्ट सॉल्यूशंस आपके जो बनते हैं फ्रॉम स्ट्रॉन्ग एसिड एंड स्ट्रॉन्ग बेस, दे आर न्यूट्रल. Okay, they are neutral, they will just get hydrated, they will not hydrolyze. फाइन. स्ट्रॉन्ग एसिड और स्ट्रॉन्ग बेस से जो सॉल्ट बनेगा उसका जो सोल्यूशन है वो न्यूट्रल होगा. एग्जाम्पल आप ले ही सकते हो सोडियम क्लोराइड और सॉरी सोडियम हाइड्रोक्साइड और HCl का. सो इट विल गिव यू NaCl एंड वाटर. सो अगर मैं इस सोडियम क्लोराइड के सोल्यूशन को वाटर में डिसॉल्व करूं, इट विल जस्ट गिव यू सोडियम आयंस एंड क्लोराइड आयंस. नाउ दी सोडियम आयंस एंड क्लोराइड आयंस, दे विल जस्ट स्टे हाइड्रेटेड, दे विल नॉट हाइड्रोलाइज. हाइड्रोलाइज मतलब ये वाटर के साथ रिएक्ट करके फिर से NaOH और HCl नहीं बना देंगे. ओके, सो दैट इज व्हाई वी आर सेइंग इट विल बी अ न्यूट्रल सोल्यूशन. ओके, फिर से एसिड और बेस वो नहीं बनेगा. अंडरस्टूड. बट अगर हमारे पास दूसरे तरह के सॉल्ट्स है, मतलब सॉल्ट ऑफ वीक एसिड एंड स्ट्रॉन्ग बेस जैसे कि सोडियम एसिटेट, सॉल्ट ऑफ स्ट्रॉन्ग एसिड एंड वीक बेस मींस अमोनियम क्लोराइड, सॉल्ट ऑफ वीक एसिड वीक बेस मींस अमोनियम एसिटेट, तो इनकी हाइड्रोलिसिस होगी. Okay, hydrolysis of these salts will happen. Like if I am talking about sodium acetate, it's a salt of weak acid which is acetic acid and strong base which is NaOH. ये completely ionize हो जाएगा to form acetate ions and sodium ions. अब ये जो acetate ions हैं, they will undergo hydrolysis to form acetic acid and hydroxide ions. Okay. अब एसिटिक एसिड क्या है, ये वीक एसिड है, तो ये मेनली आयोनाइज रहेगा. ओके, अनआयोनाइज रहेगा, सॉरी, इट विल रिमेन अनआयोनाइज. बट यहाँ पर क्या हुआ, अब हाइड्रोक्साइड आयंस की कॉन्सेंट्रेशन जो है बढ़ गई. इफ यू गेट if the concentration of hydroxide ion is increased in this case, so the solution has now become alkaline. तो इस केस में the pH of the solution will be more than 7. That's what we are discussing कि pH कैसे change होगा. If you are having a salt of weak acid and strong base, so due to the concentration of hydroxide ions, the pH of the solution will be more than 7. Similarly, if I am talking about ammonium chloride, it is formed from weak base, ammonium hydroxide and strong acid. तो अब देखो, again what will happen, ammonium chloride will give you ammonium ions and chloride ions. अब ammonium ions are the ones that undergo hydrolysis, chloride ions तो नहीं होंगी, they will not get hydrolyzed ना, because they are from strong acid. Just now we have seen कि strong acid और strong base से जो cations and ions आएंगी, they don't get hydrolyzed. So ammonium ions get hydrolyzed to form ammonium hydroxide and hydrogen ion. Now you know ammonium hydroxide is a weak base, इसका Kb इतना होता है, so it remains unionized. अब ये unionized रहेगा तो means H plus ions as it is रहेंगे, and H plus ions की concentration बढ़ेगी, तो the solution will become acidic and the pH will be less than 7. So अगर strong acid से वो salt बन रहा है, strong acid and weak base, so it will be less than 7. Okay. Now if I am, so it's an acidic salt, आप बोल सकते हो कि it is an acidic salt, और जो sodium acetate था that will be a basic salt. Okay. Now if I am talking about hydrolysis of ammonium acetate, which is formed from weak acid, acetic acid and weak base ammonium hydroxide. So the ions will hydrolyze. अब यहाँ पर जो आपकी acetate ions हैं वो भी और ammonium ions हैं वो भी hydrolyze होंगी. So you will be getting acetic acid and ammonium hydroxide. Ab they will also remain in partially dissociated form, okay, because they are weak acid weak base like this, and water also. Okay, so यहाँ पे हम calculation नहीं कर रहे, but we will try to understand कि degree of hydrolysis is independent of concentration of solution. Okay, और pH यहाँ पर आपको ये याद रखना है कि it will be 7 plus half of pKa जो आपका acid है minus pKb. Okay. All right, so pK यहाँ पर that will depend on the values of pK and pKb, right, कि कितना weak acid कितना weak base है, तो pH जो है वो greater than 7 भी हो सकता है. All right, अगर ये value positive है, and pH can be less than also 7 अगर ये value negative है. तो weak acid और weak base के base में हम कुछ नहीं कह सकते कि कौन सा salt बनेगा. So that can be acidic also, that can be basic also. Okay, मतलब जो सोल्यूशन है उसका pH 7 से ज़्यादा भी हो सकता है, and it can be less than 7 as well. Okay students, so I hope this thing is clear. Hydrolysis of salt is clear. Now let us talk about the buffer solutions. So buffer solutions are the ones that resist change in pH on dilution or with the addition of small amount of acid or alkali. Okay, means pH जो है वो change नहीं होगा, it will like remain same. okay, on dilution also or an addition of acid or base. So there are two types of buffer basically we'll see कि acidic buffer and basic buffer. So as अभी ये आपको याद रहना चाहिए because it has been asked in NEET also कि how acidic buffer are formed or how basic buffer are formed. So acidic buffer is formed with the solution of weak acid. एक weak acid लेंगे and उसका salt with a strong base. So here we are taking the weak acid which is acetic acid and उसी का salt acetic acid का salt with a strong base NaOH is sodium acetate. So this mixture will be in the acidic buffer. Okay, same goes with phthalic acid and potassium phthalate, boric acid plus borax, carbonic acid plus sodium bicarbonate, citric acid plus sodium citrate. Means एक weak acid लेना है and उसका salt लेना है with a strong base. So that will be an acidic buffer. Now basic buffer means again weak base लेके उसका salt लेना है with strong acid. So here we have taken like weak base is ammonium hydroxide and इसका salt with strong acid HCl will be ammonium chloride. So this will be a basic buffer. Same goes like glycerine plus glycerine hydrogen chloride. So these buffer solutions are used in various experiments in chemistry. Okay. Now the next is solubility product and solubility product constant. Like you know कि solubility product means saturated solution में product of molar concentration of ions of an electrolyte at a particular temperature is called solubility product. So उसको हम KSP और S simply S से denote करते हैं. Let's say for an electrolyte AB, okay, so it will give you A plus and B minus. So the equilibrium constant would be A plus B minus upon AB. Okay, if I multiply this, so K into concentration of AB will be A plus and B minus. So this is at constant temperature, this thing will be known as KSP. Solubility product is the product of molar concentration of ions. So product of concentration of A and B. Okay. And if you have a general reaction जिसमें stoichiometric coefficients भी हो A, X and Y, so KSP will be A raised to the power Y plus की power X, मतलब the coefficients will go in power. Okay. For example, if you have CaF2, okay, and Ca2 plus and 2F minus वो दे रहा है, तो इसका आप KSP अगर लिखें, तो it will be कैल्शियम आयन कंसंट्रेशन, इसका कोई कोफिशिएंट नहीं है, फ्लोराइड आयन कंसंट्रेशन, इसका कोफिशिएंट 2 है, so the power will be 2. So that will be the KSP. So this is solubility product. Okay. So solubility is S and solubility product is KSP. So what will be the, how will you find out the relation? So let's say this is an electrolyte, initial concentration is A and 0, 0. Okay. Now say let's say S is the solubility, तो इतना वहाँ पे concentration कम हो गई and here it will be XS and YS. Okay. Okay, that is the coefficient. So KSP निकालेंगे हम XS raised to the power X and YS raised to the power Y. So यहाँ से हमने KSP निकाल लिया. Okay. And if alpha is given, okay, so alpha is given means the degree of dissociation is given, so वहाँ पे हम alpha ले लेंगे. So that is simply the relationship. Okay. जैसे यहाँ पर example लिया है of CuCl2, Cu2Cl2. So it will give you 2 CO2 plus and 2Cl minus. Okay. Let's say यहाँ पर S is the solubility, तो यहाँ पर 2S हो जाएगा, यहाँ पर 2S. So KSP will be यहाँ पर 2S raised to the power 2 and here also 2S raised to the power 2. So कितना हो जाएगा 4 into 4 16 S raised to the power 4. So that will be the relation. So that will depend on a particular kind of reaction how you can find out. Okay students, so that was the last topic here. So we have discussed all the topics of ionic equilibrium, or more numericals you have to practice on this particular topic. So try to practice the NCERT questions first and then go with the previous year questions from the you can use our NTA PYQ book also. There we have given you each and every question from 2019 to 2024. So you will get an idea how the questions are asked. So you know that our book is live now. Hard copies are being ordered by the students, so don't waste time. You can order our PYQ book also, and that will be very helpful for you. And for each question, not just the question, we have given you the crisp and the detailed explanation also on how to solve that particular question. Okay. So with that, our whole chapter is complete. If you have any doubts, any queries, please comment below and tell me also whether you are understanding the things or not, or whether you want me to change something. Okay, so then I'll work on it. And please watch all the lectures of equilibrium that will be asked in your BPT10. All right, and we will be meeting in the next video lecture. So until then, take care, students. All the best for your exam. Thank you so much.